We're going to pretend it's 90 degrees outside. Okay. So it's 90 degrees outside and we have vanilla ice cream. So we're going to look at the price of the ice cream. So the schedule, okay, let me write this out here. So you're going to have a demand schedule. So remember, the demand schedule lists all the prices and quantities that a consumer would be willing to buy at different price points. So we'll start out with $2. We'll drop it to $1.50. We'll drop it to $1, and we'll drop it down to 50 cents. So for me, at $2, it's got to be I wouldn't buy a McDonald's ice cream cone for $2. Okay, so I personally would buy 0. I might buy 1 at $1.50. I might buy 2 at $1, and I might buy 3 at 50 cents. Okay, so you can see that as the price goes down, I am willing to buy more ice cream. Okay, this is my individual demand schedule. So I can graph this out, and if I graph this out, I'm going to have a demand curve. Okay, so the demand curve graphs out the demand schedule. Okay, so I'm going to graph that out over here on this graph. So the demand curve is the graphical representation of the demand schedule. And when we draw the demand curve, this is kind of important, the quantity always goes on the x-axis and the price on the y-axis. So we have price of 50 cents, $1, $1.50, and $2. And we know that at $2, 0 ice cream cones are going to be demanded. At $1.50, one ice cream cone is demanded. At $1, 2 ice cream cones. At 50 cents, 3 ice cream cones. So we can graph it out. Okay, and this is our demand curve. The giant D for demand curve. Now the assumption is that it's 90 degrees outside, right? So demand curve at 90 degrees. So this line shows only the relationship between price and quantity, holding all other things constant. Other things, what are they? Holding constant that it's 90 degrees outside, the temperature is not changing. Holding constant that it's our same vanilla ice cream cone. Okay, nothing else is different. Okay. So what we can see here is the effect of a price change. We know that if the price goes from $1 to $1.50, the quantity demanded is going to increase from 0 to 1. Okay, so if we drop the price, the quantity demanded is going to increase. Okay. If we're at point B and we drop the price from $1.50 to $1 for that ice cream cone, the quantity demanded is going to increase, and now we're going to have 2 ice cream cones demanded at $1.50. If we go from $1 to $1.50, we're going to drop the price again, and then the quantity demanded is going to increase. Okay? So if price goes down, quantity demanded is going to go up. Then, you know that this would go the other way too. What happens if ice cream cones are $1 and they go up to $2? Well, quantity demanded is going to decrease at $2. So we'll have 0 ice cream cones demanded at $2. So price goes up, quantity demanded goes down. So it's like a seesaw effect. Okay, and this is logical common sense, right? So what type of curve is this? Is this an inverse curve, a direct curve? Direct? Okay. Inverse? What does inverse or negative mean when you're talking about curves?
One goes up and the other one goes up.
Yes, one goes up and the other goes down. Prices go up, quantity demanded goes down. Prices go down, quantity demanded goes up. Okay. So we say it has a negative or inverse relationship. Okay? Questions on that? So we just have this movement along the curve. Now the way you're going to see it on your exams, and this is kind of important, anything that's related to quantity is going to be related to price. So what are some other terms for the word quantity?
Amount.
Amount. What else? So, total. What else? You guys have smartphones, right? What is another word for amount, total? Sum. Okay. What else? Huh? Cost? No, cost is a different concept. Another word for the quantity. What does quantity mean?
Bigger amount?
Bigger amount.
Please, how much?
How much? Number of. So on your test, you might see how much, number of, amount, quantity. It all means the same thing. And if those things change, amount changes, quantity, number of, it's related to a price change. And we're only talking about a movement along the curve. Okay? So if your price changes from $2 to $1, you're going to have a movement downward along the curve. Okay? So you want to remember those terms. Movement downward or movement upward. It's going to mean that you're on the demand curve. Anything that is related to number of, amount, how much, is related to quantity, and then that means that there's been a price change. Okay, because that's all this line can show, is that demand schedule for vanilla ice cream at 90 degrees. Okay?
So that's inverse when it goes up one way and it goes.
When the two variables move away from each other, that's inverse. So if you were to see it on a mathematical equation, the slope of the line would be negative. Because this is a negative slope, right? All right. So we have two key assumptions that govern this demand curve. Vanilla ice cream and 90 degrees outside. Let's say the temperature goes up to 120 degrees. Okay? So now, at 120 degrees, this is our demand curve at 90 degrees. What would happen at 120 degrees?
People would spend more.
At $2, would more people be willing to buy ice cream? Mm-hmm. So like how many ice creams would they buy? More like 5 more?
Like 2?
Like 2 more, okay. It's 120 degrees and the price drops from $2 to $1.50. How many ice creams are they going to want? 4. At 120 degrees and the price goes from $1.50 to $1, they're probably going to want more. Maybe 6. Maybe they buy some for their kids, you know. Okay, then it goes from $1 to 50 cents. What's going to happen here?
You're buying ice cream for the neighborhood.
Buy ice cream for the whole neighborhood. So we have demand for ice cream at 120 degrees. Did I change the prices?
No.
Did I change the price?
No.
I didn't change the price at all. Prices are the same. I didn't erase this column and change the prices, right? Okay. So the only thing that changed was this assumption of the temperature outside. Can I capture the effect of the temperature on my original demand curve?
Yes.
Yes? Okay, how would I do that? Graph it? Graph it, okay, so let's try that. At $2, at 120 degrees, I want 2 ice cream cones, right? Okay, so we come over here at $2, I want 2 ice cream cones. So that would mean that I am up here now. Okay, so is that the same demand curve?
No.
No, we have a different one because we have a different assumption now. Okay. When I drop the price for $1.50, I want 4 ice cream cones. When I drop the price to $1, I want 6 ice cream cones. There's 7 and 8. And at 50 cents, I want 8 ice cream cones. So if I connect the dots here, this is a new demand curve at 120 degrees outside. Okay. So note that the prices have stayed the same. What changed was what we call a non-price variable. Something that's not related to price changed. And what that means then is that we are going to have a shift in our demand curve. Okay. Can't be the same one anymore because this only works at 90 degrees. When the temperature changes, why we demand the ice cream changes as well. It's hotter, now I want to go buy more ice cream. Okay? So that means that the entire demand curve will shift to the right when we want more of the item. That makes sense? Questions? Okay. Now, what if I'm over here, D, this is point E, F, G, and H. At $2, at 120 degrees, 2 ice cream cones are demanded. I lower the price from 2 to 150. Quantity demanded increases, right? So the law of demand still holds here, but now we're on the new demand curve. What if the temperature drops to 40 degrees? The temperature drops to 40 degrees, my new demand curve is going to reflect less demand for ice cream, and that demand curve is going to shift to the left. Okay, so this will be D1, D2, and D3 at 40 degrees. Okay? So when it shifts to the left, it's getting closer to 0, that means less. When it shifts to the right, it's getting further away from 0, it means more, or increasing. Okay. Questions on this? No? All right, so we have a list of determinants or shifters that we say will shift the demand curve to the right or to the left. And you need to memorize these, not only for this class, but for the next class that you have in microeconomics and for managerial economics. So just put them in your head, because you will need to pull on them all the time. All right, questions on this? So we're going to go over what causes the demand curve to shift, either to the right or to the left. Your book calls these determinants. Determinants. Do you need to rest your arms for a little bit? Are you okay?
Yeah.
You fine? All right.
Yeah.
So the first determinant is really easy to understand. It's number of buyers. Okay. So obviously the more people you have buying ice cream, the more demand there's going to be for that ice cream. This was my individual demand curve, just mine. But if I added somebody else's to it, then we would have greater demand. Okay. If I asked everybody, what is your personal demand for ice cream, your individual demand for ice cream, and I took all your individual demands and I added those up, that would be the market demand. Okay. So as you add more buyers, what do you think is going to happen to the demand curve? Will it shift to the right or to the left? It'll shift to the right. So more buyers means that the demand curve is going to shift to the right. And of course, the reverse would be true. What has happened to the number of people buying typewriters? There are none, right? Maybe somebody who's doing the set for Mad Men, but even Mad Men has finished shooting its production, so now what has happened to the demand for typewriters? It's gone down. Nobody's buying them, so the demand curve is going to shift in which direction?
Left.
To the left. All right, so this one is really easy to understand. Okay. Another one, another demand shifter is what we call tastes and preferences. Tastes and preferences means how much we like a product. So if we like a product, if our taste and preferences increase, okay, now everybody likes dark chocolate. What has happened to the demand for dark chocolate? Well, it goes up, and the demand curve is going to move in which direction? To the right. Okay. Now, what if I told you that research has found that ice cream is very unhealthy for you and you shouldn't eat it because it'll make you die in 2 years? What's going to happen to the demand curve for ice cream?
Gonna shift to the left.
It's going to shift to the left. Okay. You don't want it anymore because it's not healthy. Yeah? Okay. The next one is price of related goods. And under this category, we have two key types of goods that are related. One is substitute goods, and the other is complementary goods. Okay. So I'm going to go through each one of these. A substitute good is something that you can eat or use in place of another, such as Nike or Reebok tennis shoes. Those are substitutes. Okay. Sometimes you can use a store brand for a regular brand. Those are substitutes. Okay. The example I'm going to use is Pepsi and Coke. For many people, those are substitutes. Okay. However, if you're the person who the waitress says, oh, would you like Coke? I mean, you say, oh, I'd like a Coke with that, and then the wait person says, we don't have Coke, is Pepsi okay? And you say, no, it's not okay. For you, Coke and Pepsi are not substitutes. But if you're the person who says, yeah, I don't care, then it's a substitute. So that's what we're talking about, a substitute. So now we're going to have two different markets. We have a Coke market, quantity, price, and there's our demand curve. Okay. And we have our Pepsi market. So let's pretend that community college has a contract with both Coke and Pepsi, and both Coke and Pepsi provide refreshments in the machines outside. And each of them sells that product for $1, and they sell 100 cans a day. Okay. Now, you go out to the hallway, you don't care which one you go to, you probably go to whichever one is closest, it doesn't matter. Okay. However, one day you go out and you discover that the Pepsi is only 50 cents. Which one are you going to buy?
Coke.
Who said Coke? Raise your hand. You guys are not in this market. I want the people for whom it is you don't care. You don't care.
I don't care for either.
You don't care for, you don't care which one, okay? So then, if the price of Pepsi goes down, what's going to happen to the quantity demanded of Pepsi? It's going to go up, okay? And we're going to have a movement or a shift of the curve.
What's the difference?
Well, good question. If it's price related, it's a movement. Okay? Remember, because that's what this line captures. Changes in price are captured by this line. So we're going to go from this point, and we will now be over here, at 150 people buying Pepsi. Okay, because the price went down. And remember, you're rational beings, and your goal is to maximize your utility. Okay, and you have a budget that you're working with. So where do these extra 50 people come from? They come from this market. So if this market loses buyers, what happens to the demand curve?
Shift to the left.
It shifts to the left. And so now, D1, D2, at $1, they're only selling 50 cans of Coke. Okay. So when the price of a substitute, in this case Pepsi, goes down, that means that the demand for your product in question, in this case being Coke, is going to shift to the left. Okay. Because by lowering the price, Pepsi is stealing Coke's customers. Well, attracting Coke's customers. Okay. That makes sense? Okay, so we're going to do price of a substitute. And so you want to put in parentheses, put here Pepsi, just in case, you're dealing with a substitute or a complementary problem. If you memorize it, you can always plug in the different name here. If the price of a substitute goes down, the demand for your product, in this case Coke, is going to shift to the left. Yeah.
I just don't get how the 150 is still on the line.
Right here, where this comes from?
Oh, right. Never mind. I did mine. I got it wrong.
Oh, right, yeah.
I
They
put
get
the
bigger.
100 at the end of the line, but you have it in the middle.
Right. Mm-hmm.
All right.
Yeah. It's where it hits the line.
Okay.
Yeah? Okay.
So then if it's not price related, that's when it's a shift. So if it's quantity related, it's a shift.
If it's quantity related, it's a price variable. So what happened here? The quantity went from 100 to 150. So if the number of Pepsi's demanded increased, number of
Quantity
quantity, that
increase.
means it's price related. So if I told you Pepsi increased the number of Pepsis it was selling by 50 units, okay, it has to be price related. Okay, because this is all that line captures. Now, are there other things that influence the demand for Pepsi besides price? Yeah, taste and preferences. People might not like it. Okay. Is there a football game on tonight? Well, if there's a football game on tonight, then people might want to go out and buy a refreshment. Okay. Other things are going to influence. And how we show those other things is through the shift of the curve. How we show the change in price is on the demand curve itself. Okay. And later on you'll see that you can graph other things, but for right now we're just doing this and that. Okay. If Pepsi were to increase its price to $1.50 a can, what would happen? There would be a movement here, right? Price would go up, quantity demanded would decrease. What would happen in the other market?
It would.
The demand would increase.
This would shift to the right. That make sense? Okay. You guys see this when you go shopping for things. So just start thinking about it that way.
Well, I have a question.
Yeah.
If, household cleaners, like when when one cleaner is lower than the other, obviously people are going to buy the lower one.
Mm-hmm.
But if the name brand can go lower than the lower one, they always wonder if that doesn't happen. Do you know what I'm saying?
Oh, yeah. Well, why doesn't a name brand go lower? So if you take like anything, right? Which cleaners are you thinking about?
Chlor.
Clorox,
Clorox and
like the great value one at Walmart.
Great Value. So Clorox is what, $2 a thing? And Great Value is maybe $1.69 or $1.50? Okay, So what is Great Value trying to do? By lowering their price,
Increase the demand.
they're trying to increase the number of people who are going to buy their product. And who is going to be the person that will go over to the Great Value brand?
People that don't care about the product.
Lower income.
Well, income is one variable, but people who, yeah, it's Clorox, it's bleach, they don't really care. So why would you buy Clorox?
Because of the commercial, I guess how big the brand is or the name itself.
People argue it smells
I
good.
don't know.
They're selling the
Yeah.
name, it smells different, you think it works better. Because Clorox is Clorox, it's a chemical compound, right? But what have they done with the advertising?
They've convinced people that it's better.
So they've affected your taste and preferences. Okay, so they're playing on another aspect of why people want that. Whereas Great Value is looking at price and trying to attract people through lowering the price, Clorox is branding itself and trying to make people feel that it's a better product through advertising, by changing the scent, okay? So they're playing on this. And what are they trying to do? They're trying to keep their demand curve from going in which direction? Left or right?
Left.
Left. They don't want it to go to the left. So they start modifying it. They modify the product, they try to appeal to you in different ways so that you want that product. Okay? And you see this in all sorts of items. You know, what is the jeans that are produced by Abercrombie or Lucky Brand or whatever's in style are made at exactly the same place that makes Levi's and other blue jeans. It's all the branding. And when you brand, you're affecting this, tastes and preferences. This is the realm of the marketer. So if you're going into marketing, this is where you're going to be, trying to keep that demand curve from shifting to the left. Okay. All right, let's go to complementary products. So complementary products are products that are purchased together, like peanut butter and jelly, printers and ink. So this morning I was going to make a peanut butter and jelly sandwich, and I'm out of jelly. So did I make my sandwich? No. That was supposed to be my breakfast, and of all things to be out of, because I'm never out of jelly, I was out of jelly, so I didn't make my sandwich. So because there was no jelly, no sandwich.
Buy that one that has both.
Yeah, the grape jelly and the swirly thing. I'm going to do that next time. So we're going to talk about complements. And I'm going to talk about two markets, hot dogs. And of course, if you're going to have a hot dog, what do you need with that? Buns. Okay. Okay, so we just had Labor Day, it just passed. The Big 8 usually has a sale on hot dogs. Okay, so we're going to pretend that they had it for $1. And in each pack, there were about 10 hot dogs in it. And then hot dog buns, they sold those for $1. And they had about, and I know this isn't true, but let's just say it is. They had 10 hot dog buns in the package. Okay, so I think it's always like 10 and 8, you know.
They mess it up for hamburgers because I buy it from my bar all the time. They always sell like a package of like 20 hamburgers and the buns come in like 6.
Yeah. And why do they do
Hot
that?
dogs is usually just like, but hamburgers is always off.
It's always off. They do that so you buy more bread, and then if you buy more bread, you have to buy more hot dogs. You know, that's what they do. It's like milk and
Just
cornflakes.
almost double patty.
Yeah, double patty. All right, but let's assume that this is the case. All right. So you go in with your $2, you buy your hot dogs, you buy your hot dog buns, you have a meal for 10, right? 10 kids. However, let's say you go in and you discover that the price of the hot dog buns has gone to $2. So if the price goes up, what's going to happen to the quantity demanded of hot dog buns? It's going to go down according to our law of supply and demand. There'll be a movement along the curve. What is the impact of this price increase over here in the hot dog market?
People will buy a hot dog.
Well, people will figure out another thing.
Will it decrease? The demand?
Yes, the demand curve will shift to the left because the price of the complement went up.
What if it's like a variable like hamburger buns? Could you eat a hot dog with hamburger buns or something?
Then you're
But
using then you're using a substitute product,
all right.
right?
And you get a cup.
Or you could, you
Yeah. Yeah, or you could do corn dogs or something. But in your book, I'm sure you read it, there's a concept called ceteris paribus, right? And ceteris paribus means what? Other things equal. So what are we doing when we look at our models? We're holding all other things equal or constant. Okay, so we're assuming that this is what we went in to buy. Okay? And yes, once you go there and you discover the hot dog buns are too expensive, you might still buy the hot dogs, but now you're doing something else. Okay, you've changed your you're gonna do something else with it. You're no longer making hot dogs for lunch. Okay. All right, so if the price of hot dog buns goes down, let's say it goes down to 25 cents, what's gonna happen to the demand for hot dogs?
To the right.
It will shift to the right.
Which one would down 10 cents? I'm sorry.
Hmm?
Which one would down 10 cents?
Hot dog buns. Okay. So here, if the price of a complement goes up, I'm going to put it down here. If the price of a complement goes up, demand for the product will shift to the left. So think about buns and hot dogs. If the price of the complement goes down, demand for the product will shift to the right. Okay, questions? Does that kind of make sense? Think of some other goods that you consume together.
Cereal and milk.
Cereal and milk, yes. What else is consumed together? So we read the article last week about the rising price of eggs. Yeah. Did we not do that?
No.
Sorry. Oh, well. Oh, I know why. Because we got stuck on the production possibilities curve.
Mm-hmm.
Yeah, sorry. So what goes with eggs?
Bacon.
Eggs and bacon, eggs and ham. The price of eggs is going up. Are you likely to buy sausage or bacon?
I like the
Yes. Yes, because you have a demand curve that is unwavering. Okay. Another thing that's going to shift the demand curve is income. Under income, we have two key categories.